10.2 is about the area of trapezoids, rhombuses, or rhombi as I like to call them, and kites. The area of a trapezoid is 1/2 the height times base 1 plus base 2. Again, height makes 90-degree angle with the base, but again, it's going to be the side opposite that as well. Then that will be your base 1 or your base 2, depending on, it doesn't really matter how you call it. Area of the kite or the rhombus is 1/2 of diagonal 1 times diagonal 2. So you need to know your diagonals for rhombi and kites. So if we look at problem 1, it's a trapezoid. This should be a right angle right there. So we know it's area equals 1/2 of the height, which is in this case 309, times base 1, and it really doesn't matter what you call it, but 511 plus base 2, which is 205, doesn't matter. And then just punch that all in your calculator, you get 110,662. I'm sorry, 22. In problem 2 here, we're getting a little bit back into trig. Remember I told you special right triangles, all that stuff's coming back into play here. We end up having base 1 and base 2 here. And remember, our area is 1/2 base 1 plus base 2 times the height. Doesn't really matter there. Or do you put it in? So what's my height? So if I draw my height down there, understand that it forms a triangle here. Well, if this side's 5, my side down here is 2. Well, that's one of those special right triangles. So we're going to make our chart 30, 60, 90, S radical 3, 2S. And then understand that's what it equals here. So the 2 is across, 60 is down here, so 2 is across from the 30, so 2 goes here. Again, plug it in here, across from the 60, which is our height, is going to be 2 radical 3. So I get my height to be 2 radical 3. And that's where special right triangles come handy. It's really quick to do it that way. So area equals 1/2 of the height, which is 2 radical 3, times base 1, which is 7, plus base 2, which is 5. Okay, that gives me 1/2 times 2 is gone, so I end up with radical 3 times 7 plus 5, which is 12. And then just multiply those together, and you end up with 12 radical 3 because it wants it in simplest radical form. Problem 3 here, we're finding the area of a kite. We end up with, again, area equals 1/2 of diagonal 1 times diagonal 2. So what's diagonal 1? And again, it doesn't matter what you call diagonal 1 and diagonal 2, but it's the whole thing. So part of it's 3, the other part's 3, so 1/2 of that whole one is 6 times the other whole one, which in this case is 7. So you punch that again in your calculator, you get 21. Again, pretty simple. A lot of times it's about just solving. Problem 4, we're finding the area here of a rhombus, and again, area equals 1/2 diagonal 1 times diagonal 2. And again, we have the diagonal, so 2.5, we know that this is also right here, change color so you can see it, this is also 2.5 because we know diagonals bisect each other on rhombi. Okay, well how do I find this here? How do I find what x is? Well, if I look, this appears to be a right triangle, you can see it, so I can use Pythagorean theorem here. So my hypotenuse is 6.5. 6.5 squared equals x squared plus 2.5 squared. Okay? X squared equals, I don't have a calculator on me, so I'm just going to write it. The square root of 6.5 squared minus 2.5 squared, because I'm just subtracting it over. 2.5 over. I end up with x squared equal to 36. So x equals 6. And again, I probably should erase this square root. Sorry, x squared equals that. Let me fix this up. Minus 2.5 squared. Square root both sides. That's how I got x to be 6. Got a little ahead of myself. So if this is 6, this other side here is 6 as well. Okay, so we end up with area being 1/2 of diagonal 1, which is 5, 2.5 plus 2.5, times diagonal 2, which is 6 plus 6, which is 12. And that's going to be 30.